Yo, 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 it's your boy Mr. B bringing you some maths, and today we're gonna do set 3, paper 2H. Let's go. Question 1, 3 questions. So, first thing we have to do here is we need to label the sides. So, we know it's not Pythagoras because we're finding an angle. So, that angle determines what the sides are. So, we're gonna get adjacent, opposite, and hypotenuse. Then I'm gonna choose the formula. I'm finding an angle and I'm using A and H, so the formula that has A and H is K. So finding an angle, I get C equals A over H. Then substitute and solve, I get that cos X is going to be equal to 8.3 over 9.5. So X is going to be the inverse cos, so cos minus 1 of 8.3 over 9.5. You put that in your calculator and you get 29.1 degrees. Question 2, we have a compound interest question. So first thing, let's write down the formula. Don't use the formula given on the formula sheet. Naughty old man is way better. So nu is original times multiplier to the power of time. Then let's find the multiplier here. So we always start with 100%. Then 5% compound interest means that we're going up. So 105%, change that to a decimal 1.05. Now we have everything we have. We can substitute and solve. So nu, what we're trying to find, is going to be original, which is 2000, times the multiplier, 1.05 to the power of time. The time is 2 years. You put that in your calculator and you get that the new amount is 2205. Question 3, an angles question. So we need to find that angle here, there with x. The first thing we can find here is angle ACB. So ACB, take a look at the diagram, is going to be the same as DCE, and the reason for that, so this 67 degrees, and the reason for that is they're vertically opposite angles. So we put 67 degrees on our diagram, and that's done with the reason. From there we can find angle ABC, because ABC is going to be the same as angle ACB, which is 67 degrees, and the reason for that is that they're both base angles of an isosceles triangle. Put that in the diagram. Then from there we can find x, because x plus 67 plus 67 is going to be equal to 180 because of angles in a triangle. So x is going to be equal to 180 minus 134, which is 46 degrees. Question 4, a probability question. First thing we're going to do here, we're going to find the probability of her getting the 2 6s, because it's much easier to find the probability of her getting 2 6s than listing all the scenarios where she doesn't. So probability of 2 6s is going to be 1 over 6 times 1 over 6, which is 1 over 36. Then we can find the probability of her not getting 2 6s, because the probability of not getting 6 and 6 will be 1 minus the probability of her getting the 2 6s, which is 35 over 36. Question 5, a proportion formula question. So first thing to do here, we're going to set up a table. So we have P, which is the price of the mirror, and R square, which is the square of the mirror's radius. So we know that when the P is 36, the radius is 20, so 20 squared. If one thing on the column is squared, everything has to be squared. Then we're going to cross multiply, but how do I know this is direct proportion? Well, basically, if the question is not telling you, if the question just says is proportional, it's going to be direct proportional. Unless, you can take it from context that it is inverse proportional, but for in this case it will be direct. So P times 20 squared is going to be equal to 36 times R squared. From here we can make P the subject of formula, so you're going to get a 400P is 36 R squared. Divide both sides by 400, you're going to get a P is 36 R squared over 400. Simplify the fraction, you can put 36 over 400 in your calculator, and your calculator is going to simplify it for you, but that's going to give you 9R squared over 100. Question 6, we have a forming, solving / inequalities question. So first thing, in order to help me visualize here, I'm going to actually just draw a rectangle. So one of the sides is going to be the smaller side, so it's going to be the width is going to be x. The length is 9 centimeters longer than the width, so the length is going to be x plus 9. So now that I have my rectangle, I can set up an inequality and solve. So I know that the perimeter is less than 200. So the perimeter, x plus 9 plus x plus 9 plus x has to be less than 200 centimeters. I'm going to collect like terms here, and I'm going to get the 4x plus 18 is less than 200. Then I can solve, take away 18 from both sides. I get that 4x is less than 182. Then I can divide both sides by 4, and that gives me that x is less than 45.5. We read the question, and the question says that the width is a whole number of centimeters, so the greatest possible width of the rectangle is 45 centimeters. Question 7, we have a 3D Pythagoras question here. So we have the cuboid shape case or whatever, and you want to fit the walking stick. That means that what it's actually asking of us here is for the diagonal size of this cuboid, and it's asking us if that is bigger or smaller than 60 centimeters. Here I'm just going to go straight into 3D Pythagoras. Now you can only do that if you're finding the whole diagonal of a cuboid, not for any other shape. But if it is a situation, you can just do that. The diagonal squared is equal to each of the shorter sides squared added together. To solve this, you take square root of both sides, so the diagonal is going to be the square root of 30 squared plus 20 squared plus 45 squared. You put that in your calculator and you get that that is 57.6628 plus whatever. So the walking stick is 60 centimeters, that means that it won't fit. Remember, just saying it won't fit without the working out will get you 0 marks. Question 8, a constructions and loci question. Disgusting. You're probably not going to get this in your GCSE, but it's here, so let's go. You're going to need a compass in order to do this. So first, metal tip at the origin, you draw a semicircle. Then at the points where the semicircle touches each of the lines, you're going to put the metal tip and draw an arc. So first arc, second arc, there you go. Then you are going to draw a line that cuts the angle in half, which is this line over here. Now this is the same as the bisector of the angle, but that is also the locus of all the points that are equidistant, so same distance from between AB and AC. Question 9, another percentages question. So here the sale price we don't have the original price. So there's 2 ways of doing this. You can use Naughty Old Man, which for the calc paper is perfect, but I'm gonna show you how to do this using proportion, because that is better in case a question like this shows up for the non-calc paper. So we're just going to set up a table which has 464 is equivalent to 80% of the price, x is 100%, which is what we're trying to find. We're going to cross multiply here, so x times 80 is 80x, 464 times 100. I'm just going to leave it as is because the calculator is going to do all the work. Then to solve, I'm going to divide both sides by 80. X equals that big thing over there, which I'm not going to touch again because this is a calculator paper. So let the calculator do the work for you, and you get that x is equal to 580. Again, you could have gotten to that answer with Naughty Old Man. If you did, that's 100% okay. Question 10, a standard form question, one of the rare ones that shows up on the calc paper. But when it shows on the calc paper, just remember to put things exactly as they are on the calculator. So we're trying to find how many times the surface of Jupiter is bigger than Earth's. So this means that we're going to do a division. So we're going to get 510072000 divided by the other big thing over there, which gives me 121.9033283. Do not round your answer here. Very important. Then we're going to convert that to standard form. So I'm going to rewrite them here with the digits a bit spread apart, so it's easier to visualize what I'm doing. So in order for it to be in standard form, I need to make this number into a number between 1 and 10. So I'm going to move the decimal place once, twice. So I'm going to get 1.21 blah 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 times 10 to the power of 2 because I moved the decimal point twice. Question 11. So here we have an averages question, mainly to do with mean. Those are quite common, so let's go. First, before we even start, let's remember that mean is the same thing as the total when you add up what you're looking for divided by how many data points. And you can rearrange this to get that the total is the how many data points you have times the mean. We're going to use this quite a bit in this question. So let's go. Let's find the total of A first. So the total of A is going to be how many there are in A, which is 25, times the mean of A, which is 67.8. So the total is 1,695. That means that if we add all the marks of everyone in A, we would get 1,695. Now I'm going to find the total for both classes. So the total for both is going to be how many students in both classes, which is 55 students, times the mean for both classes, which is 72, and which will give me 3,960. Again, this one means is you're getting all the marks for every student in both classes and just adding them together. Then we can find the total for B. The total for B is going to be the total for both classes minus the total for A, which will give you 2,265. And then we can find the mean of B. The mean of B is going to be the total for B divided by how many students there are. So 2,265 divided by 30. You put that in your calculator and you get 75.5. Question 12. So we have a transformation question which is asking us to see which transformation it is. Now, first of all, we see what is happening here. So the shape is changing direction, so we know it's not a translation. And we see that the shape is the same size, so it's probably not going to be a rotation. It's not going to be a reflection here. There's no mirror line that will do all of that, so we know it's a rotation. Knowing that it is a rotation, how many degrees it is? You can see that the shape only goes like a quarter of the way, so it's going to be a rotation. 90 degrees, because it's only a quarter of a full turn. And we're going from A to B, so that's going to be 90 degrees clockwise. That is the quote-unquote easy part. Now to find the center of rotation, we're going to get our tracing paper. We're going to draw our shape A, and we're going to be trying a couple of different centers to see which one works. So we're going to start with 1, 3. You put your pencil on 1, 3, you rotate 90 degrees, doesn't work. Go back to normal. Then try a different center. So I'm going to try 1, 4 now. Pencil on the center, rotate your shape. Works perfectly, so the final answer is rotation 90 degrees clockwise about 1, 4. Question 13. So we start with a compound measures question. That's the easy part of the question, part A. So first we need to find the mass of the pyramid. So mass is density times volume. Just draw the pyramid. It will take you 10 seconds and it saves a lot of marks. So mass is density times volume. So the mass of the pyramid is going to be the density or the volume, which is 3,000, times the density, which is 8.5. You put that in your calculator and you get that the mass is 25,500 grams. You put that as your answer and you lose a mark because you didn't read the question properly. The question is asking you to give your answer in kilograms. So in order to do that, we need to divide it by 1,000, so you get that the final answer is 25.5 kilos. Then, part B, calculate the volume of the pyramid, give your answer in meters cubed. So this is a similar shapes question, but with a lot of unit conversions here, because everything on the small model is in centimeters, everything on the actual pyramid is in meters. So first thing we need to do here is we need to change the measurements to the same unit. I chose to go from centimeters to meters. If you did the other way around, that's fine, but because the final answer is in meters squared, I just found that this was easier, but both of them will require some work. So 25 centimeters into meters, I'm going to divide it by 100, which gives me 0.25. Then I need to find the side scale factor. So the pyramid, the base is 225 meters, so the side scale factor is going to be 225 divided by 0.25, which gives me 900. Then I need the volume scale factor. The volume scale factor is going to be 900 cubed, which is 729 million. Then, can I start finding the other volume? No, because from the question before, the volume was in centimeters cubed, so we need to change that to meters cubed. So, 3,000 centimeters cubed divided by 100 cubed, because remember, if from centimeters to meters you divide by 100, from centimeters cubed to meters cubed you divide by 100 cubed. So divide by 100 cubed and that gives 0.003. And now finally we can find the volume of the pyramid, because that is going to be the volume of the model times the volume scale factor. You put that in your calculator and you get 2187000. Question 14, another forming and solving question. So, first thing we need to do here is we need to work out the perimeter of the small square. We're going to work out both of them. But the small square is a square, so that's just going to be 4 times x plus 6. Remember, if you're times in here, you need to use brackets because it's a complex term. So that gives you 4x plus 24. Then the perimeter of the large square is going to be 3x plus 5 plus 2x plus 5 plus 3x plus 5 plus 2x plus 5, which is 10x plus 20. Then we can form an equation and solve. So it says that the perimeter of the small square is equal to 3/5 of the perimeter of the rectangle. So from here we can solve. So 4x plus 24 is going to be equal to 3/5 of 10. So 10 divided by 5 is 2, times 3 is 6, so 6x. 20 divided by 5 is 4, times 3 is 12. So then we can start solving. So get the x's on one side, so take away 4x from both sides. You get a 24 is 2x plus 12. Then get rid of the 12, so take away 12 from both sides. You get that 12 is equal to 2x. Then divide both sides by 2 to get rid of the 2. You get that 6 is equal to x. That is not what the question is asking though. The question is asking for the length of the side of the square hole. So we're going to substitute to find the length. So x plus 6 is the length, so that is going to become bracket 6 plus 6, which is 12. Question 15, so we have an expanding triple brackets here. There are different methods of doing this. I think the safest one is table, so that's one that I'm going to do here, but you do you. Right, tables. So first we need to do the first two brackets. So we're going to need a 2 by 2, so we're doing 2x plus 1, x minus 3. You set up your table, then you multiply, top times right. So 2x times x is 2x squared, 2x times minus 3 is minus 6x, plus 1 times x is plus 1x, plus 1 times minus 3 is minus 3. Yes, I know you don't need the plus 1 next to the x, but I actually think it makes it easier when you're collecting like terms. So then we're going to collect like terms. X squared, I only have that term, so it stays the same. The x's, I have minus 6 and plus 1. Minus 6 plus 1 is minus 5, so the result is minus 5x. And then numbers on its own, or constants, we only have the minus 3, so it stays. So I multiply the first two brackets. Now I need to multiply the result by the last bracket. So I'm going to set up a new table. So this one is going to be 3 by 2. And I'm going to get 2x squared minus 5x minus 3, and then x plus 5. Same thing as before, multiply, top times right. 2x squared times x is 2x cubed. 2x squared times 5 is plus 10x squared. Minus 5x times x is minus 5x squared. Minus 5x times 5 is minus 25x. Minus 3 times x is minus 3x. Minus 3 times 5 is minus 15. Then we collect like terms. If you did it properly, it should be easier to collect them inside the table. So x cubed, we only have 2, so 2x cubed. X squared, I have those two terms, 10 and minus 5. 10 minus 5 is plus 5, so plus 5x squared. X's, I have minus 3 and minus 25, so minus 3 and minus 25 is minus 28, so minus 28x. And then finally, minus 15 is the only constant, so minus 15 is over there. So final answer, 2x cubed plus 5x squared minus 28x minus 15. Part B, now we have a subject of formula question, so we're going to write it out. And we have a subject of formula with two separate variables because we're trying to make our subject of formula. So first thing we need to do, we need to expand that bracket. So left hand side is the same. A times m is am, a times r is ar. Then we got everything expanded. We need to get all the r's to one side, everything else to the other side. So I'm going to start by getting ar to the other side by taking away ar from both sides. That gives me 5r plus 1 minus ar equals am. Then everything else goes to the other side, so I need to get rid of the plus 1, so I'm going to do that by minusing 1 on both sides. That will give me 5r minus ar equals to am minus 1. So now that I have all the r's on the left, this is the step that people get confused with. I need to make two r's into 1, and the way that I do that is by factorizing. So I'm going to factorize r out, which gives me r bracket 5 minus a equals to am minus 1. From here, I can divide both sides by 5 minus a, which gives me r equals am minus 1 over 5 minus a. Question 16, we have a circle theorems question here, not that difficult question. So first, we're going to find that angle over there, angle ABC. So look, angle ABC is going to be equal to angle PAC, which is 56 degrees. Why are they equal? Have a think if you haven't done it by yourself. They're equal because of alternate segment theorem. Look, it's a triangle and a tangent, and those two angles are facing the same direction, so they will be equal. So let's update the diagram. Then I can find x, because x plus 56 plus 75 is going to be 180 because of angles in a triangle. So x is going to be equal to 180 minus 131. So x is equal to 49 degrees. Question 17, variance tree question. This is a long one, so put your seatbelts on. So first thing, we know that those are both north lines because it's bearings, and it says that B is east of A. So this angle over here has to be 90 degrees, which means that we can find that angle over there, angle ABR. So ABR is going to be 360, which is angles around a point, minus 220 minus 90, which is 50 degrees. We can also find that angle over there, angle BAR, because that angle over there is also 90 degrees, and the whole bearing, according to the question, is 160. So that angle, angle BAR, is going to be 160 minus 90, which is 70 degrees. Now that we have those two angles, we can find angle ARB. So ARB is going to be 180 minus 70 minus 50, which is 60 degrees. And the whole reason why we found those angles is that now we can start finding things that are relevant for us to find TR later. Because look, now we can find side AR because we have two sides and two angles opposite to them, so we can start using sine rule. So look, AR over sine 50 is going to be equal to 12 over sine 60. There are two sides and two angles opposite, and so we can use sine rule. So we rearrange this a bit. AR is going to be 12 times sine 50 over sine 60, which you put in your calculator and give you 10.616, etc., etc. Do not round it at this point, just leave the whole thing. Then I can also find this angle over there because that angle is going to be 90, which is the bottom side of that 180 degrees, minus 70, which is the other angle, which gives me 20. Now that I have all of those information, I can find TR because I have two sides and the angle in between them, so I can use cosine rule in order to find TR. So a squared is equal to b squared plus c squared minus 2bc cos a. Remember, don't get you confused with the letters. All that matters is that the a's are the things that you're trying to find. B and c do not really matter. So in our case, we're gonna get TR squared equals to the other two sides, don't matter the order, 5 squared plus 10.61, etc. squared, minus 2 times 5 times 10.61, etc. times cos 20. You get that TR is the square root of that massive thing, and you put in your calculator and it gives you 6.2 to 1 decimal place. That's it for this one. Hope you guys had the time of your lives doing a past paper instead of doing something else with your weekend. Alright, see you next time. Borges out.